My dear colleagues, this is the first session of the topic subject specific and context specific pedagogy. I, Dr. T.K. Basantia from National Resource Center for Education, Central University of South Bihar, Gaya, Bihar, welcome you all to this session. In our previous 3 sessions of the topic subject specific and context specific pedagogy, we have covered the learning heads like background of subject specific pedagogy and philosophical base and types of subject specific pedagogy, pedagogy of language and pedagogy of social sciences. The present discussion will help you to understand the learning head, that is pedagogy of science. In this session, we will cover 3 main points. Those are understanding science context, basic pedagogical principles of science and pedagogical strategies and techniques of science. I believe that this discussion will familiarize you with some important domains of pedagogy of science and will create a foundation or base for use of pedagogy of science in practical classroom endeavor. Let us get started. First, let us move to discuss understanding science context. Science as a body or field of knowledge mostly deals with physical and natural realities. Science may be defined as a systematic approach or method of studying physical and natural phenomena which include both living beings like plants and animals and non-living materials like stones, water, glass, etc. The areas of physical science, chemical science, biological or life science, earth or material science, etc. are generally studied under science. The concepts like organism, force, heat, pressure, gravitation, light, cell, current, molecule, friction, metal, non-metal, energy, chemicals, etc. are learned or studied in science. One unique feature of science is that science has 2 significant dimensions. One dimension is science is considered as a content or subject, and the second one is science is considered as a method or approach. Either of the dimensions or viewpoints in the context of science is accepted. Science as a subject includes many areas or concepts of learning, some of which we have discussed a little time before. Science is considered as a method or approach of acquiring knowledge. As a method or approach of acquiring knowledge, it is based on logical reasoning which includes induction and deduction. While induction allows for drawing conclusions or formulating theory or deriving principle from particular instances or examples, deduction creates ground for verifying the conclusions or testing the theory or justifying the principle by applying those on particular instances or examples based on their respective contexts. It is better to take an example to clarify the meaning of induction and deduction here. It is known that French researcher Pierre-Joseph Pelletier and Benjamin Caventou in 1820 first isolated quinine, a kind of medicine from the bark of a tree in the genus Cinchona. Now, let us take a hypothetical situation where a doctor used the medicine quinine to cure a person from a disease, malaria. Initially, the doctor prescribed the same medicine to large number of malaria patients. In all cases, it was observed that because of the application of the medicine, the patients are cured from the malaria. Hence, the doctor generalized that quinine cures malaria. This is an example of induction where the doctor generalized that quinine cures malaria by studying the effect of quinine on many malarial patients. Only drawing generalization or formulating theory is not enough. The generalization or theory must be verified through deduction to complete the whole process of induction and deduction. It means in order to verify the generalization, it must be applied in many situations for which it is meant. Here, in order to verify the point that quinine cures malaria, quinine must further be prescribed to or applied on patients suffering from malaria and effect of quinine on the patients must be observed. Induction and deduction are complementary and one is incomplete without the other. While we use scientific method for creating knowledge or deriving a theory or extracting principle in respect of solving problems, we follow certain steps. Broadly, the steps include identifying the problem or difficulty, formulation of tentative solution or a hypothesis for the problem or difficulty, collection of data based on the tentative solution or hypothesis, analyzing the data to test the tentative solution or hypothesis, drawing the conclusion or result on the basis of analysis of data, and at last verifying the conclusion or result. For solving many issues or problems, scientific method is followed which is based on these steps as we discuss now. And these steps are used in research as research uses scientific method for solving the problem. Science as a method has its applicability in varied areas and its scope goes beyond natural or physical sciences. Science as a method is also applicable to study social phenomena, behavioral domains and many others. Therefore, social sciences, behavioral sciences, etc. are also treated under the domain of science, but these differ from natural and physical science with respect to their features and properties, and these are treated as subsidiary sciences. Here, in this context, our discussion will focus on primary science, which includes physical science, life science, etc., but not on secondary sciences, and the primary science, which is basically dealt in school level. Development of science is a boon to the humankind. Science is in the process of unveiling the mysteries of the universe or understanding the mysteries of the universe for the benefit of the humankind. It has created path for development of modern world. It has reduced disease, hunger, poverty, ignorance, death rate, stress, deformity or disability in one hand. In other hand, it has made human life more subtle, luxurious, comfortable, sustainable, relaxed, healthier and exciting. It has reduced the space and time factor in human life and made this world very small for the benefit of the human being. It has heightened the media and communication, business and economy, literacy and education, culture and art and craft, agriculture, healthcare, weather forecasting and almost all aspects of human life. Science has touched the life of modern society such an extent that no modern life and society can be visualized without science. Science helps in our every walks of life, starting from eating, doing, growing, playing, observing, listening, speaking, reading, writing and creating to sleeping. Recent developments in applied science, especially nanotechnology, genetic engineering, biotechnology, microbiology, molecular biology, atomic science, space science, marine science, etc. have brought significant revolution for the development of individual and society. Realizing the importance of science, it has been included in our different stages of school education. Science in each stage of school education has its own focus. For example, at primary stage or class 1 to 5, science is taught as an integral part of environmental studies with a focus to help the child to understand physical and natural environment found around him or her. At upper primary stage or from class 6 to 8, science is taught as a separate subject which includes contents mainly from the areas like physical sciences, biological sciences, etc. in an integrated manner with a focus to develop knowledge domain and process skills in science. Process skills here refers to the way of doing science or way of conducting activities and experiments in science. As science is regarded as a method, so learning of doing science or learning of process and steps of science becomes an important aspect of science learning. At the secondary school stage, that is in class 9 and 10, science is studied as an independent subject and more unfolded unlike upper primary stage, and in this stage its contents are mainly drawn from the areas of physics, chemistry and biology. In this stage, along with learning science contents, main focus is given on scientific way of understanding, problem solving and analysis. In higher secondary school stage, that is in class 11 and 12, multiple branches of science like physics, chemistry, botany, zoology, etc. are studied as optional or independent subjects in order to facilitate the domain specific knowledge and process skills among the learners of science, focusing more on laboratory skills as compared to other school stages. Some of the important objectives of study of science at school level are to enhance the conceptual knowledge of science, to develop process skills in science which includes observation, quantification, manipulation, experimentation, analysis and interpretation, inferring and prediction, etc. by using both theoretical and practical knowledge. To develop scientific temper or objective way of understanding nature or natural phenomena. To shape positive attitude towards the world of science or appreciate the world of science for the survival of the whole ecosystem. To use the science for the benefit of the living beings and protection of the nature. To enhance the critical analysis and ability to inquiry in understanding the phenomena of the nature and the universe, etc. The paradigm or horizon of science differs from the paradigm or horizon of other subjects like mathematics, social sciences, languages, etc. Science has a distinct identity and it is based on distinct principles. The pedagogy of science must also be based on same principles which conform to the principles of science. Let us explore the basic pedagogical principles of science one by one. Firstly, science follows nature, goes with nature and tries to understand nature. Friends, in nature, different phenomena to some extent have orderliness and regularity. For example, in nature, initially birth, then growth and maturity, then decay or death is a orderly phenomenon of a plant or animal life. Further in nature, in our life, first childhood comes, then adulthood comes and then old age comes. And this order of life never goes in opposite direction or in any other way. Science believes in the orderliness of nature and tries to understand the different aspects of orderliness in terms of their cause and effect relationships or properties. Science hardly defies nature and natural law. Secondly, science is based on objective reality. The great nature of science is that science believes in truth which is based on impartiality, accuracy and principle of logic. Science applies systematic method to understand a phenomenon. Science is based on factual knowledge and empirical evidences. Science uses observation as the sole method for understanding a phenomenon. As science is based on empirical or observed truth or fact, so it hardly bothers for moral implication of a phenomenon or it is out of the domain of morality. However, the process and product of science can be used in consonance with the morality and value system of an individual or society. The misuse of the facts discovered and invented in science becomes the cause of destruction in different fronts. Further, science believes on objective truth. Its result or outcome can be objectively applied in different fields or we can say verified repeatedly. Thirdly, all sciences have strong predictive or forecasting roles. All of us are aware that the ultimate purpose of using science is to solve the existing problems and to forecast about the future problems and their solutions. Science provides objective way of predicting forthcoming or future change or development or problem. For example, a biologist after studying the fertilization can forecast the visibility of a genetic character in future generations based on the fertilization. Space related forecasting, climate related forecasting, nature related forecasting, etc. are the contribution of science to a great extent. Fourthly, science believes in change. One important feature of science is that the principles, laws, theories, etc. of science are not always constant or absolute or final. One theorem of science to explain an event may be refuted or replaced by other theory of science in course of time because of the understanding of its nature with more depth. Science is in the process of evolution and exploration. Previously, scientists were claiming that there are 9 planets in solar family. Nowadays, many scientists claim that there are 8 planets in solar family. The changing nature of science allows for broadening the outlook of science, increasing the content of science, relooking the methodology or process of science, and creating strong ground for application of product of science. One important point here I want to indicate that science way of knowledge creation is based on joint method of induction and deduction, and both are complementary to each other. The generalization based on induction is not always absolute in true sense, as in induction one proceeds from particular to general or generalization, and generalization based on induction is derived from the study of some particular instances. Fifthly, science to a great extent uses quantification method for objective understanding of events and processes. We know that science uses some mathematical tools like symbols, number system, etc. for quantitative understanding of different events. But there is difference between science way of understanding and interpretation of knowledge and mathematical way of understanding and interpretation of knowledge. Science is fact based, field based, and based on empirical analysis and interpretation of data. But on the other hand, mathematics is based on certain axioms or principles which may have existence without empirical and observed facts. These are some of the basic principles of science. These basic principles of science, along with many other principles of science, must be focused in pedagogic or teaching learning process of science. Now let us shift our focus of discussion towards pedagogical strategies and techniques of science. In teaching learning of science, those strategies or techniques are used which pave the way for gaining objective and universal knowledge based on science. Pedagogy of science must inculcate knowledge and skills involved in science in learners. The pedagogy of science should be more target oriented and specific. It must facilitate the practical knowledge of science, or it must be practical oriented. Practical orientation here does not mean that science must be out of theory or must reject the theory part of it. The theory part of science must substantiate practical aspect of science, as science is based on observed or empirical truth. Let us discuss some important pedagogical strategies and techniques used for science teaching learning, like experimental method, heuristic method, and problem solving method. First, we will take experimental method. Every one of us knows that experiment is very important in science. Experiment is a control procedure or operation carried out in order to describe an existing truth or fact or law in one hand, or to understand an unknown truth or fact or law in another hand. Creation of scientific knowledge is heavily based on experiment. An experiment may be conducted in order to prove that oxygen helps in burning, but it does not burn, which is an established truth or fact. The experiment can be conducted in this way. Take 2 candles and fix them on surface. Add fire to both the candles so that those will start burning. Cover one candle with a glass jar so that outside air cannot enter inside the glass jar. Since one candle is covered by a glass jar so that outside air could not make an entry into the jar. The moment the oxygen is exhausted within the jar, the candle will stop burning inside the jar. Whereas the other candle which remained outside, not in glass jar, will continue to burn till the candle gets exhausted, as the candle does not have the problem in getting oxygen. From this experiment, it is proved that oxygen helped in burning the candle, but it was not burnt. Experiment may be conducted to discover and understand the unknown truth. Different science related issues or concepts like friction, presence of pressure in atmosphere, photosynthesis, etc. can well be taught through experiment or experimental method. Now let us discuss heuristic method. Heuristic method is a method of discovery. Etymologically, the word heuristics is derived from Greek word heurisko, which means discover. This method puts the learner in the place of discoverer. This method claims that instead of making a child a passive learner, it is better to make a child or learner an independent discoverer or problem solver. H.A. Armstrong is the significant contributor to this method, and this method was primarily evolved to be used in science. Though nowadays this method is widely used in many other disciplines including mathematics. In this method, a problem is not presented in front of learner. Rather, clues or hints relating to a problem are given to the learner. The learner discovers the way or method to solve the problem and solve the problem according to his or her own feeling and own pace. This method is less structured and more based on trial approach of learning. This method is characterized by critical understanding and independent way of thinking and doing a task. Learners get sufficient scope to use their creativity and innovation in solving a problem of science in this method. Problem solving is a method of teaching learning which is used synonymously with heuristic method. But some sorts of differences are found between two methods. While heuristic method is less structured, problem solving method is more structured. While the steps of problem solving method are very much defined and systematic, but in heuristic method, a learner devises the step for solving the problem in his or her own way. While problem solving is more scientific, heuristic is more creative. But both problem solving and heuristic approaches have common goal, that is solving the problem. Let us take an example of using heuristic method here. For example, presence of metals like iron, gold, copper, etc., as well as some non-metals like sulfur, phosphorus, carbon, etc. to the learners. Let the student to explore or discover the differences among them. Here, the teacher will not inform the differences between metals and non-metals. Rather, the learners themselves will find the differences among metals and non-metals according to their own observation. Difference between living and non-living, difference between plant cell and animal cell, water pollution and purification, plastic and their types and uses, etc. in subject area of science can well be learnt through this method. Now let us shift our focus to problem solving method. In problem solving method, we use scientific approach and its well defined steps to solve the problem. This method is a practice based method and based on the real world events. It is a learner centered method or approach. In this method, a problem is defined well. Hypotheses or tentative reasons of the problem are formulated. Data or information relating to the hypothesis or tentative reasons of the problem are collected. The data or information are analyzed. Conclusion is drawn from the data and at last the conclusion or result is verified. Let us take an example of the use of problem solving method in biology area of science. In a garden, some plants were found which exhibited ill health condition and some other plants were found to be in good health condition. In order to understand the causes of poor health condition of the plants, problem solving method was used to find out reasons or causes of the same. To understand the causes of poor health condition and accordingly to improve the affected health condition of the plants was the main objective of the problem of study or investigation here. Now, the learners started reflecting on or investigating the causes of the poor health condition of the plants. Some important causes investigated were soil or mineral condition, water supply, presence of chlorophyll in leaves and presence of sunlight in relation to the plants. After making proper investigation or collecting proper information from the environment of the plants, it was found that soil or mineral condition was good, water supply was normal, presence of chlorophyll in the leaves was proper, but the plants were located under the shade of some big trees for which the plants were deprived of adequate sunlight. On the basis of the investigation, necessary step was taken to provide adequate sunlight to the plants by cleaning the surrounding, which is very much essential component for the process of photosynthesis in plants. After some days, it was observed that the health condition of the plants improved. This investigation proved that the presence of sunlight in addition to mineral from soil, water supply from surrounding and presence of chlorophyll in leaves are essential factors for the process of photosynthesis which produces nutrition for the plants. Like this issue in science, many other concepts or topics in science like removal of air and water pollution, speed and motion, balancing, separation of components of mixture, acceleration, reproduction, etc. can well be dealt with problem solving method. Besides these pedagogic strategies and techniques, many other pedagogic strategies and techniques like inquiry method, inductive and deductive method, project method, etc. are regularly used in science teaching learning. While using these strategies and techniques, the respective tenets, assumptions and principles including scope and limitations of the strategies and techniques must be considered. In the process of teaching learning of science, learners must be given sufficient exposure to science environment. They must get exposure to use and handle different apparatus of science which may include laboratory based apparatus for developing laboratory skills. The environment of the child itself can be used as the tool or apparatus for science learning. Project, practical work, etc. must constitute the significant aspect of science learning. Learners must be given freedom and scope to be everyday scientist or small scientist in one hand and big scientist or special scientist in another hand. Colleagues, while using pedagogy in the context of science learning, the different pros and cons of science learning must be understood, and for understanding different pros and cons of science learning as well as for blending pedagogy in science learning, our discussion made in this session may be helpful to you, me and all. I hope that you enjoyed this session. Let us wind up this session now. We will meet ourselves in our next session in this topic. Thank you for being with me. Bye friend. Okay, thanks.